Okay class, so now we move on to question 9. Let us try question 9 together. We have figure 5 with a 6 microfarad capacitor that are going to charge through a resistor of 2 mega ohm. So this resistor is 2 mega ohm. So mega means 2 to the power of 6 ohm. Okay, so mega is times 10 power of 6. The resistance of the microammeter is negligible and the resistance of the voltmeter is high. Okay, so voltmeter is used to measure the voltage across the capacitor and the microammeter is used to detect the current that flow in the circuit. So our switches is closed. So we close our switches. So A, what is the potential difference of the battery when the switches is closed and the capacitor is fully charged to 4.8 to the power of negative 5 coulomb. So class, we want to find what is the voltage of the battery. So we want to find V when our switch is closed and the capacitor is fully charged to a charge of 4.8 to the power of negative 5 coulomb. So I try to relate the charge with the V. So there is only one equation that we can relate the charge with the voltage supply. We have Q equal to CV. So our charge, when we are fully charged, our voltage is, our charge is 4.8 to the power of negative 5 coulomb. So the capacitance is 6 to the power of negative 6. So we can find the V. So the V will be, so when you do calculation, you will get 8 volt. Okay, so this one will be our answer for question A. Then question B. Question B, we want to calculate the current. We want to find the current when the switches is closed and sketch a graph of microammeter reading current against time t. So we want to sketch graph current against time. Beside that, we want to find the current when the switches is closed. So we want to find the current. So I try to relate. So we want to find what is the current that flow. So the current we can relate with the voltage and also the resistor. You might use your prior knowledge, Ohm's law. We might use our prior knowledge in Ohm's law. Voltage can be related with current and also the value of resistance, V equal to IR. So we already calculate the voltage from question A, 8 volt. So I want to find the current. The resistance is 2 to the power of 6. So I'll get the current is 4 to the power of negative 6 ampere. So this is the initial current when the switch is closed. Okay. Then we want to sketch graph microammeter reading current I against time. Yeah, we want to sketch the graph. So current against time. So current is our y-axis. The unit will be microampere. I put it in microampere because I use microammeter to measure the reading. So it must be measured in microampere. Then the time is in seconds. So I have labeled the axis. So what are going to be the shape of my graph? The variation of current with time. So we have to determine whether this is a charging or discharging process. So we have the presence of the battery. So we know that this is a charging circuit. So since this is a charging circuit, so if you recall the concept we learned through the videos, the second video in our lecture 2.2, during the charging process, our current will start to decrease from the initial value, I0, decrease exponentially with time. Okay, so this is the variation of current against time. So what is the initial value we have to put in? So the initial value we already calculate in the questions is 4 to the power of negative 6 ampere. Okay, so we put in the initial value. So this will be our sketching for the graph. Okay, so we might also put in another important point in this graph. Another important point in this graph is the time constant. If we want to put in the time constant, we understood that during charging process, when we reach the time constant that equivalent to RC, our current will decrease until 0.37 of its initial value. So you might put in this information also in your graph sketching. Okay, so then we have done with question 9.